Hello friends, I'm Engineer Nasir. In this video, we will do sample calculation to select the duct support. First, we will select the angle or channel size for duct support. For it, we will make calculation for deflection, bending stress and for shear stress. We will do a sample calculation for selection of steel angle for the duct support. Let us assume we have a straight duct having dimension 700 by 400 and the sheet used for the fabrication of duct is 22 gauge and the distance between two support is 3 meter. First, we will calculate the duct weight that will be supported by a single support. For it, we will take the duct length equal to the distance between two supports, which in our sample calculation is 3 meter. Then we will calculate two types of duct weight. Number 1, total duct weight, which we show here by P. And number 2, weight of duct bottom and duct top, which we are showing here by P1. As we are using sheet 22 gauge and for 22 gauge, weight is 6.86 kg per meter square. Then we will calculate the area of the duct for 3 meter length, which is 6.6 meter square. Then we multiply it by 6.86. Then the total duct weight is equal to 45.28 kg. Similarly, the weight for the duct bottom and top is 28.81 kg. To calculate the deflection, we use this formula. And for this formula, we need the duct weight that we already calculated. A, we are using 50 mm clearance between the hanger rod and the duct on the support. If both side clearance is 50 mm and duct width 700, then the length of the angle that we are using for support will be 800 mm. So L will be 800 mm. And the modulus of elasticity for the steel is 200 GPa. Moment of inertia we will select from the steel properties table of the angle. We use this table to select the angle properties. First we will check for angle size 40 by 40 by 3 mm to check if this angle is safe to work for our duct support. From this column we will select the cross sectional area, which is in centimeter square, and from here we will select the moment of inertia, and this column is for section modulus. So for the angle size 40 by 40 by 3 mm, cross sectional area is 2.336 centimeter square and moment of inertia in centimeter is 3.53 and section modulus is 1.21 cubic centimeter. Weight and angle properties we fill in this table. For duct weight we consider 25% safety factor. Then the duct total weight will become 555.246 Newton and the weight of bottom and top of the duct will be 353.28 Newton. A 50 mm. Section modulus we have converted to millimeter cubic 12100 and moment of inertia will become in millimeter 35300. The value of modulus of elasticity in Newton per millimeter square will be 200,000 and the cross sectional area for the angle in millimeter will be 233.6 millimeter square. When we apply this value in this formula, we got the value of deflection equal to 0.8958 millimeter. To calculate the maximum allowable deflection, we use this formula, length divided by 360. Then by this formula, we got maximum allowable value for the deflection is 2.22 millimeter and our calculated value is 0.89, which is less than allowable value. Or you can use the maximum allowable deflection limit from SMACNA. As per SMACNA, maximum deflection we can have up to 9.5 millimeter. The formula given in SMACNA is little bit complicated. So to make it more simple and more safe, we consider it point load at center. Then when we apply these values in this formula, The deflection in this angle is due to this duct weight 0.83 millimeter, and the allowable maximum deflection for this angle length is 2.22 millimeter. So as per deflection, this angle is safe to use for this duct support. Now we'll do calculation for shear stress and bending stress using point load method. Then maximum allowable duct weight for this angle is 2462 as per shear stress, and as per bending stress maximum allowable duct weight is 63.7 kg. Both these ducts are more than our duct weight, so as per shear stress and bending stress value also this angle is safe for this duct support. To select support for different size of angle, we make an Excel table. You can see for a duct size 700 by 400 22 gauge, total weight for one support 45.28 kg. When we use 40 by 40 by 3 millimeter angle, deflection in the angle is 1.00 millimeter and allowable 2.22, and as per bending stress allowable duct weight is 63 and our duct weight is 45. As per shear allowable duct weight is too much, 2462, so this angle is safe for this duct weight support. But if we want to use the same angle for another duct size 1000 by 500 and gauge 20, total duct weight for one support 76.65 kg, then the deflection in this angle became 4.44, which is greater than allowable deflection 3.05. And as per bending stress, maximum allowable duct weight is 46 kg and our duct is 76. So this angle is not safe for this duct support. Then we need to select another size of angle. When we select 50 by 50 by 4 millimeter angle, then the deflection value in this angle is 1.72 and allowable 3. And also as per bending stress, maximum allowable duct weight is 95, our weight is 76, so this angle is safe for this duct support. Again, if we need to use the same angle for another bigger size 1300 by 700 gauge 18, then the deflection value became higher than allowable, and as per bending stress allowable duct weight is less than duct weight, so this angle is not safe for this duct. Then we will go for next size of angle 75 by 75 by 5 millimeter, and for this angle deflection also is less than allowable angle, and as per bending stress maximum allowable duct weight is higher than the duct weight, so this angle is suitable for to use for this duct support. Selection of anchors. For selecting anchor for duct support, we use its specification sheet. You can see in this sheet the first column is showing the anchor size, and from here we can select the maximum recommended shear load in kilonewton, and it is maximum recommended tensile load in kilonewton. For hanging rod, we will consider the maximum recommended shear load value. For duct support, normally we use minimum 10 millimeter rod size, and for it we will select the 10 millimeter anchor. For 10 millimeter anchor, for hollow concrete slab, we have the maximum recommended shear load value 3.6 kilonewton, and for non-crack concrete slab, maximum recommended shear value is 4.93. If you need to convert it in kilogram, then you can multiply it by, divide by 9.81 and multiply by 1000. Then you will get the maximum recommended load for 10 millimeter anchor equal to 502.548 kg. Selection of threaded rods. To select the hanger or threaded rod for duct support, you can use this table from ASME B31.1. In this table, the first column is for rod nominal diameter, and if you want to select the corresponding weight in kilogram, then you can select from the last column. For a threaded rod diameter 3 by 8 millimeter inch or 9.4 millimeter, the corresponding maximum load value is 276 kg, and for a rod of diameter half inch or 12.5 millimeter, the maximum recommended load is 512 kg. So From the first column you can select the load diameter, and from the last column you can select the corresponding maximum load in kilogram.